everybody. So this is just going to be a quick review of exponents, and maybe we'll get to scientific notation, but my guess is that's just going to be in a different video. So go way back in your head to knowledge, b to the 5th times b to the 7th. What do you think? Yes. Now, at any point in time, if you're like, dude, I know this, then that's why we do this on video. You just get to fast forward it and all is well. So have at it if you need to. The answer is b to the 12th. But if you're like, I just have never understood why it's b to the 12th. Well, here's what happens. When you have powers, that means repeated multiplication. So b to the 5th is actually b times b times b times b times b 5 times. Then b to the 7th is b times b times b times b times b, b, and b. So if I now counted them up, that's b multiplied by itself 12 times. That's where you get the b to the 12th. So what's really happening is you've got, all right, b to the 5th times b to the 7th. The exponents add. You're not adding, you're multiplying. It just happens that, interestingly enough, that just adds right there. So, here is the rule, which you've been covering this since you were in, 7th, 8th grade, so you've got it. All right, so just try the next couple. 2 to the 2nd times 2 to the 3rd. Hopefully you're saying 2 to the 5th. Got it. All right, but then what happens if we put a whole bunch of letters and a whole bunch of numbers together? So in these, I'm just going to quick go 6 times 5. So you find your number values. I'm going to do that. 6 times 5 is 30. Then I'm going to go to my x's. X to the 4th times x squared. And then I'm going to go y to the 3rd times y to the 7th. So hopefully as you got through that, you got it faster than I did. So this is 30. That's a 30, not a 36. 30. Times x to the 6th, y to the 10th. So if you just break it down piece by piece, it's great. So, product rule, if you're multiplying, what do you do with the exponents? You add them. Quotient rule says if you're dividing them, you subtract, right? Now, a long time ago, when we did this together for the first time, we kind of talked about who wins by how much. So if you look at A, really what happens is that parentheses around the -2, that's really important. You have like -2 times -2 times -2. I'm going to put the negatives in there. They just might not get in there right away. 1, 2, 3, 4. -2, -2. 1, 2, 3, 4, 5, 6. Let's put another one over here. Okay, so we got 7 of them divided by 4 of them. How come you put parentheses around those? Just because I thought of it. It doesn't really matter. I'm just trying to make a point. That's a 2. Do you see how you have 7 of them on top, 4 on the bottom? That means 1 cancels, 2 cancels, 3 cancels, 4 cancels. It doesn't matter which ones you cancel out. You end up with -2 to the 3rd power. Now, because that's a number, you can come up with that. So, -2 to the 3rd power is actually 1 over 8. Do you remember why that is? And it's going to be negative. So, we'll hit that rule in a second, but that might just jog your brain. So let's look at the next one. What am I going to do? Well, 30 divided by 5. 30 divided by 5 is still 6. So none of these problems are subtraction problems. It just happens that because of the canceling, when you have the variables, you end up with the exponents canceling. So like here, we now have x to the 12th divided by x to the 3rd. Well, that means you have x times itself 12 times divided by x times itself 3 times. 3 of them cancel, and so you end up with x to the 9th. And then the last one, y to the 9th divided by y to the 7th. Well, on the top, you have y multiplied by itself 9 times. Bottom, you have y multiplied by itself 7 times. And so 7 of them cancel out. So the top wins by 2. There's 2 left after you cancel them. The zero rule for exponents. B to the fourth times b to the fourth. What's anything divided by itself? 1. So therefore, anything to the 0 power, 1. So this right here is 1. This is 1. This one is -1. Why? Because this question, what this is actually saying, because that negative is not in a parentheses, the 0 is only going to the 6. So that actually says -1 times 6 to the 0 power. Well, 6 to the 0 power is 1 times -1, -1. All right, D, anything, the whole thing is in parentheses, so that changes it up. That's 1. E is 5. How come? Because what that says is, since there's no parentheses in there, that really says 5 times x to the 0. Well, x to the 0 is 1, and times 5 is 5. All right, negative integers as exponents. So let's look at this one. This, because it's b to the third divided by b to the fifth, that means you have 3 multiplied by themselves on the top, 5 on the bottom. Well, what happens? Yeah, you go through cancel, cancel, cancel. So you actually have 1 left on the top. Don't forget the 1 on the top. And you've got b squared on the bottom. So really, you end up with 1 over b squared. Or you could say, hey, I know that 3 times 5 is -2. That's also b to the -2 power. But if I were right in front of you, I'd have you put your hands out with your fists, one on top of the other. And then that negative doesn't make things negative. It just rotates it. And you'd flip your whatever hand used to be on the top to the bottom. It's a reciprocal. The negative exponent makes the reciprocal. So if b is a real number, not equal to 0, because you can't do 0 on the bottom, it all blows up, and n is a natural number, then we get 1 over b to the n. And if you have 1 over b to the -n, that flips up, it reciprocals it up to the top. So really, wherever it's negative, you want to move it to the other side of the fraction bar to make it more positive. All right, so 9 to the -2nd. So what I do, just like, okay, 9 to the regular second would be 81, reciprocal. So I get 1 over 81. Again, at any time, if this is too fast, I'm going fast because this is you've covered it a ton of times, but just stop, re-listen, and all is well. All right, do you see how this one says -2 to the negative fifth power? So -2 to the regular fifth power would be -2 times -2 times -2 times -2 times -2. So your answer ends up negative because of that negative right there, not that one. So negative 2, 4, 8, 16, 32. But because of the negative exponent, it reciprocals, we've got a 1 on top. Now this one says 6 to the -2, but it's on the bottom, so 6 squared is 36. That negative exponent reciprocals it up to the top, and you get positive 36. All right, this one, we're going to break it down into pieces. So you've got your number piece, you've got your x piece, you've got your y piece. All right, let's look at the 7. Is there any exponent affecting that 7 in the yellow highlight? The answer is no, so it doesn't change. The x is to the -5th power. Well, we want it to be a positive power. We always try to leave things in positive powers. So that means it goes x to the +5th down here, and y squared ends up here. So that ended up looking wonky. 7y squared all over x to the 5th. Power rule. Power to a power, you end up multiplying the powers. I'll show you that cute little graphic that we did when you were younger that just will help you remember all of this. Okay, so that means that's like b squared times b squared times b squared times b squared, which gives you b to the 8th. So because of the repeated multiplication, you end up multiplying those. So that means b to the m to the n power gives you b to the m times n power. There's your cute little rule. So let's try a couple. 2 to the 2nd to the 3rd is 2 to the 6th. Now that one I can just come up with. So 2, 4, 8, 16, 32, 64. Okay, this one. Y to the 5th to the regular 3rd would make y to the 15th because of that negative exponent. Reciprocal. All right, this one. B to the negative 4th to the negative 2nd. Well, negative 4 times negative 2, because of the repeated addition, gives you b to the positive 8. So, the product to a power rule just says, oh, this one. Hey, look. You can, on this, it distributes to all the pieces. So this, do you see how you've got negative 2y squared in parentheses? That means you break it down and do negative 2 to the 4th and y squared to the 4th. So it distributes in. Negative 2 to the 4th. Negative 2 times negative 2 times negative 2 times negative 2 gives me positive 16 y to the 8th. All right. Quotient power rule. We use this all the time. If you have something in parentheses that's a fraction to a power, you can just split it apart, which is beautiful. So this gives me negative 3 to the 4th power all over x to the 4th power. Negative 3 times negative 3 is 9, so 81 over x to the 4th. All right, this one, same thing. It goes into both. So I get x to the 6th over 4 to the 3rd. So 4 times 4 is 16, times 4 is 64. X to the 6th over 64. So do the exponents out if you can, if it's just a number. Okay, so how does that go here? Why don't you try them real fast and then come back to me. All right, there's the first one. So you get negative 27, x to the 12th, y to the 15th. Take a moment and do the next one if you didn't already. All right, and this one gives you 14, x to the 6th, y to the 10th. Take a second. Did you get x to the 6th? How come it's that way? Figure it out and do the next one. All right, this one we get negative 7 over x to the 4th because the bottom wins by 4. And then you get y to the 12th on top because that y to the negative 8th, that goes up here as a positive. So y to the 12th. So there's just a quick review on all of your exponent rules. And if you need some scientific notation, come back for the next video.